Oh, we're recording, but I have no visual. There we go. We're ready to go. Okay. 1-4 is what we're going to go for today, guys. 1-4. This one is just talking about inequality. Okay. So, really quickly, I want you guys, what does this mean? X is greater than 5, right? Oh. So, this is an inequality. We're going to start with inequalities today. Now, some of our goals aren't just going to be straight out obvious. We're going to actually solve it just like we did yesterday with linear equations. Does that make sense? Okay, we're going to figure that out a little bit. But I want to introduce you to what we call interval notation and set builder notation. Okay, there's two different types that people use. And to be honest with you, with this being my first year teaching the 1010 course, I don't know what your final is going to have on it. Because I've never seen it. Because it doesn't come from me. It comes from UVU. Does that make sense? So therefore, I'm going to teach you both ways. So that when it's there, you know which one you can use. Does that make sense? Okay, this, right, to be honest with you, is already in set builder notation. It just needs a little bit more. This is how we would write it. You guys know these lovely little thingamajigs that I'm not very good at. Brace. I don't do very good at those. That's what it is. You'd say x such that, that's what that line means, is such that, okay, x is greater than 5. This is set builder. Okay. Now, I'm going to have us graph this really quick first on a number line. You guys notice how it's only one axis, or I mean one variable? So I'm going to do this on a number line, where this is 0, here's 5. Now notice, guys, I didn't do 5 tick marks, because just what if it's 2,000? Do I want you to do 2,000 tick marks? No, kind of give me a guidance that this is 0, here's another number, give it a number, right? Okay, so let's go back to some things. This is greater than, not a greater than or equal to. So you should have learned this some time ago. My daughter, who's in 7th grade, so but it's been a while. That's what I'm saying, because I don't know how often you've been using it. Is this an open dot or a closed dot? Open. This is an open. Remember, if it was an equal to, it would be a closed dot, because that would actually work for a solution. You guys remember that? So this is an open dot at 5. Okay? Now which numbers are greater than? To the right. So I just shade that way, and I have to put an arrow. Why do I put an arrow? Because that says it keeps going. Correct? Okay. Now, when I teach, I personally like what we call interval notation. That's my favorite one. But like I said, I don't know exactly what they're wanting, so I'm going to show you both. Okay? What number does this start at? What actually makes the solution work? It starts at 5. Once again, it does not include 5, right? So instead, we're going to use, instead of open dots or greater than, we're going to use parentheses and brackets. Okay, what does a parenthesis mean? Is that an open dot or a closed dot? That's an open. Because I have an open, I'm going to use a parenthesis. Okay. How far does this go? Forever. What's another word for forever? Infinity. And we all know Buzz Lightyear's full of poo, right? Cannot get beyond infinity. Every time I watch it, my kids are like, you can get beyond infinity. I'm like, no, you cannot. No such thing. Right. So once again, because we can never touch infinity, will it ever be a bracket? So this is called interval. And notice these are the same answers, just written differently. Okay?
I don't know if you guys have seen interval notation. Probably, hopefully last year, because usually as the higher you get in math, they use interval notation more than step building. I like interval notation. I didn't like it. But once again, not knowing that in your book it has step builders, so I just trying to wonder that's what they're going to also use sometimes down the year. Does that make sense why I'm doing what I'm doing? All right. If you took me next year, you might know a little more. I wouldn't have to do both. But that's where we're at.
Okay, so today on your homework, a lot of times you're going to be answering the problem via graph, via set builder, and entry. Okay? You agree with me on that? Let's get to a problem. Okay, so treat this just like an equal sign. Okay, how do I solve this? Add 4. Good. Okay. Then what? Divide by 3. Notice that now that's looking like what we started with on the previous example, wasn't it? Okay, so we're going to finish this up. A, let's put it in set builder notation. Okay, really only thing different is you go crazy brackety thing, X bar, which is the bar means such that X is less than or equal to 17 thirds. Curly brace. Hi. Then Y such that Y. Okay. Now, me personally, I always like to graph it before I do integral notation. That's me. I'll show you the reasoning why. Okay, so here's my number line. Here's 0. Here's 17 thirds. Petrus, what's your first name though? Carissa. I got the last name because I remembered somewhat of that, but can you help me? Is this an open or closed dot? Closed because of the equal to, right? Because could I plug 17 thirds in here and that's still a true statement? Is 17 thirds less than or equal to 17 thirds? Yes, hence why I can actually include that on my graph because it actually works in the equation. Whereas in the previous example, 5 is not less than 5, right? Hence why it was still open. Because let me ask you this question. What's the largest number less than 5? It's something even larger than that. 4.999. Right? There's really no such thing as the largest number less than 5. Hence why we got to use 5, because it can go right up to it, but not be it. Right? Hence why we use open dots and closed dots, because if we really think about it in terms of mathematical sense, there's no such thing as the largest number less than 5. Right? There isn't. Because there's an infinite amount of 9999s that we could actually do with it. Right? Okay. All right. So this time, though, it can be a closed dot because of the equal. Thank you, Carissa. I appreciate it. Now, am I going to things to the left or to the right? We're going left because of the fact that it is less than. Right? Help me name again? Eli. So once again, we're going this way with an arrow. Correct? Now, the reason why I like interval notation is because it's basically, what do? We say, what number do we start at? Now, how far? First off, also interval notation is You always want to start with the lowest number to its highest number. So how far left is this going? Negative infinity. How far right does this go? 1730. And this would be a bracket. That would be a parenthesis. Okay. This is interval, set builder, interval, set builder, graph. Okay? Any questions on that? Okay. Now, I lost my notes today. We'll get to our rules. Okay, how would I graph something like this? Actually, let's not do that. Okay. How would I graph that? What is that saying? Anyone want to help me with what it's saying? Help me name again?
It would just be
Taylor.
Taylor, yeah. And then it would just be like a set amount of the bar.
Uh-huh. Because really that's saying, oh, x has to be greater than 0, greater than or equal to 0, but has to be less than 3. So it's not going on from just that, it's stopping. Right? This is actually called an AND statement. When it's this way. And I'll show you, we'll talk more about it, but don't worry about it right now. But here's what the graph will look like. Here's 0, here's 3. What does 0 get, a closed or an open dot? Closed. Does 3 get a closed or an open dot? Open. And notice we're looking for the material between those two numbers, right? Does that make sense? Okay, whereas, once again, how would we write set builder? Crazy little brackety deal. X such that you guys see basically your answer is going to be in set builder. Now, what is my interval? How far left did it go? Anaí? Because I said your name right.
Oh, yeah, you did.
0. Perfect. I can't go any further than 0, right? Now, is that a bracket or a parenthesis? Bracket because it is an include. Right. How far to the right do I get to go? 3, and that's going to be a parenthesis. Okay. How are we feeling? Nothing too hard yet, right? And guys, you guys understand this isn't the whole year, isn't like easy remembering stuff. We'll get a little deeper. It's just, this is the very beginning, right? Okay. Oh. Now, really quick, I want to talk about an or statement. Okay? Allison. Okay? I want you guys to tell me whether this is a true or a false statement. Okay? If me or Allison are going to the movies. Let's say I don't show up, but Allison does. Is that a true statement or a false statement if I said me or Allison? Still true, because one of us still showed up, right? On an or statement, it's just something one of us has to be there. What if I show up and she doesn't? Still a true. How about if we both show up? Still true, because we can either have one of us, both of us, or one of the other, right? So on an or statement, basically just one of the things has to work. So give me a solution to this answer. Give me an x value that could work for this solution. Remember that saying x has to be less than -5 or x has to be greater than equal to 5. Just tell me a x value. 0 would not actually work. Because is 0 less than -5? No. 0 greater than 5? So that one actually does not work. How about 6? Is 6 less than negative 5? No, that's a false statement. That's like her not showing up to the movie, right? How about 6 is greater than or equal to 5? That's a true statement. So that's like me showing up to the movie and she didn't, right? Is that a true statement? Yeah. Does that make sense to everybody? Is on an or statement just means that one of the things has to work in one or the other, or both. Okay? So if we graph this though, let's hurry and quickly graph this. Just wanted to make sure you guys understood what or meant in terms of math. Or means it has to either work in the first part, or the second part, or in both. Okay? All right. So if I do this on a number line, here's 0, here's negative 5, here's 5. Okay? This blue right here is going to be this guy. So we're starting at 5. Open or closed? Closed. Right or left? Right. Okay, are there with me? This guy's going to be in black. Okay. Open or closed? Open because the it's not an equal to. Okay, left or right? Left. So, by the way, this shows us our answers. Okay, any number that's over here, negative 6. Is negative 6 less than negative 5? Yeah, so that's true. So automatically, because that's true, this whole statement's true, right? Does that make sense? 10. Does it work in this one? No, but does it work in this one? Ah, it works. Is there anything that they share? They don't share anything. So there's nothing that's going to share. So they're either going to be, one's going to be true or the other one's going to be true, but neither is going to be true at the same time. Right? Okay. How are we going to do this as a interval notation? First off, let's do set builder. Oh, how hard is set builder? X such that. There you go. There it is. All right. Set builder, as soon as you get the answer. I mean, it's going to be nice for answer purposes, but it's like, okay. Interval notation. Okay, always start with the least amount. What's the least amount that I can use? Negative infinity. Where can I go to? I have to stop at negative 5, don't I? Can I ever touch negative infinity? Hence why it will always be in parentheses. I can never get there. Okay? Can I touch negative 5? Is it allowing me to be negative 5? It's saying going up to it but not including it, right? Okay. Is that as much as the answer it is? Now notice we skip a little bit of the area, right? Then we start up again. What's the lowest amount on this region? 5. Bracket or parenthesis? Bracket to where? Infinity. Now, the only thing we're missing is the union. Union, not you, okay, is another word for or. Okay. Another word for or. You know, you won't be able to use that one on the ACT? Yeah. Como say what? Did you talk to me or did you talk to me? I don't know what I have to do. Como say, huh? It's actually huh. How do you say huh? My English. Okay. All right. I think we're rocking and rolling. How do you guys feel so far? Doing okay? Nothing too hard? Nothing right? Okay, I got a question for you guys though. Give me any number. Any number. 7. I love it. Okay, give me any number. 3. That's a true statement, right? Okay, I'm going to show you guys some things. And it's very silly. You guys can just pay attention if you want. This is really not notes, but just here we go. If I add 1 to both sides, what do I get? Is that still a true statement? Okay, what if I divide by 2 to both sides? Still a true statement. What if I times by 3 to both sides? Still a true statement. Okay, what if I subtract to both sides? Right. Hey, so does adding change the value? Keeps the same sign. You guys see what I'm trying to get at here, maybe? You guys remember the rule. Okay, let's come back to this guy. Let's go ahead and notice up here I divided by 2. It didn't change the sign. But what if I divide by a negative 2? Okay, is this a true statement? No. Okay, and to be honest with you, okay, why? Why does it not become a true statement anymore? If you think about it, when we're on a number line and we're on the positive side of our number line, okay, meaning anything 0 and greater, aren't things closer to 0 smaller than things like this? Correct? Let's go to the other side. What about the negative side? Isn't it directly opposite? Things that are closer to 0 are greater than things that are further away. So therefore, by timing by a negative, okay, or dividing, isn't division just multiplication in there though? Okay, when timing by a negative, that puts us on another number line. Which then, the process of inequalities has to switch because the thinking of them are completely different. If I'm on the positive number, things closer to 0 are smaller than things that are farther away. Whereas on the negative, things that are further away are smaller than things that are closer. So remember, anytime I multiply or divide by a negative, I need to switch my sign. Might want to write that down for you, because that's a common mistake on test. Okay, so remember, anytime you multiply or divide by a negative, is it multiplying or dividing? No. It's multiplying or dividing by a negative that makes it the other part, because then you're using opposite values. Okay? Does that make sense to everyone what I'm trying to go for there? Does that make sense why I was doing this though? Kind of show you that, hey, it doesn't change it. Until somebody showed me this, I never really understood why. That was just a rule. How many of you guys ever really got that? Why do I have to switch? Did anybody? I really found this like, sometimes in math, I just always took it because somebody told me it, right? If that makes sense. This is the rule. And then like, as I become a teacher and people show me things, mind blowing, right? Because I've just always taken it for granted. But when I'm like, oh, that makes total sense, right? All right, so now we can do some other things. Okay. All right, I'm actually going to push pause on the video, and I'd like you guys to try to solve this on your own. Okay? If it's you, it's maybe not as hilarious. Any questions how I did that? Just distributed, right? Key thing here that a lot of people forget is to distribute to both. You guys did mostly that. You guys did really good. My first grade class had about 7 kids that just do it to the first. Right? You gotta remember to go to both. Here, key thing is a -1, so I gotta distribute them to both people, right? Another key thing. Does that make sense? Okay, combine like terms on this side. How many P's? 2 P's. -1 is greater than 2. Excuse me, that would be 5, wouldn't it? Is your cousin / sister in my class? I have a pink bill. I don't know. Learning their names. You could even get homework from one of them. Oh. I don't have my A3 Signatory 3 honors. You've already taken on. I've already taken Signatory 3.
I don't remember. I just went to math.
How many of you guys all got that? Most of you. Tyler! Hi. Did I mess up? Oh, I asked how many got that, huh? Whew, sometimes, sorry. Okay, let's put it in interval. P such that P is greater than 2. Can you tell I just stained that one? Yeah. I didn't even know that was other choices. I got brown.
Wow.
Look at that, it's got brown.
Oh. I didn't like it. No. I think they actually like, like, grandma just like, no.
My dad, his favorite color. Yeah, and so sometimes that's a healthy person. If you go enough, you're healthy. If you don't, there's issues. All true. I'm watching Alone, and this guy just got kicked out because he can't go poop. And it's being recorded, so. We couldn't have a bowel movement. How far do we go left? 0. How far to the right? Oh, what the hell? I did that wrong. I need to Control Z that thing.
Look what you did.
My mind's stuck on trying to help you out that I'm losing all this other stuff for them.
We talked to you.
See, look, good. Peer pressure. Oh, that's the worst thing ever. There we go. Feel good? Any questions there? Anything really different than what we did yesterday except for what? The notation. The solving's pretty simple, except what's the only thing we didn't do? Did we ever divide by negative? Times by negative? We've already
Losing all my stuff. Is your shirt part of your choker?
I remember when chokers came in, at least when I was a kid. They came in during 1992 and 93. Oh no, but I remember Katrina Weaver. She had one. She was the hippie of our class. She was very forward thinking. Look at that. That's some good brown. I've already told you what I thought. Have I not? Yes, yes you have. Okay, start doing it right now. I'll answer you today. Take math. Accounting's not math. Huh? Okay, does anybody remember we kind of did this earlier with Taylor, right, on his question? What is the number I'm going to multiply this whole thing by? If I multiply everything by 2, that would suck. 6.
Oh, okay.
Because once again, I'm looking for where it would be a common denominator. Where does 3, 6, and notice what's underneath the 2 even though he's not there, a 1, right? Where does 3, 6, and 1 meet up at? They all meet up at 6, correct? Cut.
Want that? Right click to change, is that you?
Change the actual color palette.
Timesing by 6. Here we go. What's 6 times 2? 12. Divided by 3. 4. Stay in counting.
Oh.
6 times negative 5. Negative 30 divided by 6. 6 times 2. Right? Very simple. Once again, they look a little bit nasty, but after one step, we get into something we feel comfortable with. Mrs. Domgard, you looked at it a little different, so I'm going to help you out. As we multiply fractions, because if I do it to one side, I can do it to the other, and it's still okay, right? They're equivalent statements. So as I multiply fractions, remember, you go straight across. But I'm doing it to every single thing in. So 6 times 2 is 12, 1 times 3 is 3, 12 divided by 3 is 4. You see where I'm at now? That's how you would change it to be an equivalent value, right? Okay. All right, so then this is pretty simple again. Okay, so I'm going to subtract the 4. What the heck? So negative 5x is greater than 8. Here we go. What do we see? We're going to be dividing by what? Negative 5. What does that do to our sign? Flips it. Do I want decimals? Do I want mixed numbers? That's like cooking.
I hire people for this one. Not effective. I make tacos.
Wow.
I have 5 things on my list. Not very many. So you get tacos, pork tacos. I can make a grill, make a nice hamburger. I can do breakfast food. I can do chuck. What is it?
I'm not a bad grilled cheeser. What else is really on my agenda that I can make? I can make a mean spaghetti, but not crushing my own tomatoes. Not that hippie hop. Okay, here we go. So, once again, interval notation. X such that x is less than negative 8/5. Okay? On a number line. Why are you so red? Did you start giggling? Are you laughing at me? I need to laugh at what? What? I'm sorry. Oh, in your mouth. Go. If you want to go take care of it, brother. I'm sorry. Tissues right there. Okay, brother. Inkish. Okay, so this is a open circle looking to the left, right? So therefore, plug it in. Negative infinity to negative 8/5. Are you bored? Be honest. You be honest with me. Okay, I like you anyway. Oh! Ow! 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 Ow!
Serves you right, Buckley.
This is 1-5, by the way. Oops, I am missing the word or. So on compound inequalities, that means I'm going to have two statements, basically. Once again, on an or statement, I got to find where one works, where the other one works, or where they both work, right? Does that make sense? And their answers together, with that being said, is the final answer. Okay? So, we're going to just solve each equation by themselves. Yes, ma'am. X minus 3 is less or equal to negative 5. Is that what you're asking? Yes. I look maybe further distant. I can understand. I'll shut up. Sometimes I get a little sensitive about my handwriting, but I'm like, sometimes when it's good, I'm like, come on. You know, I understand when it's bad, but. Okay, I'm going to add the 3. Mix that up. Brush your teeth 40 times tonight. Okay. Now, on these ones, we cannot tell the answer until we're all the way done graphing it. Because the graph might switch our answer from this. Okay? Does that make sense what I'm saying? Maybe not yet, but I'll show you. Okay? Here's my number line. Here's 0. Here's negative 2. Here's 3. This guy's in red. This is 1-5. Okay? So, close dot, that direction. Okay? Open dot, this direction. Do they share anything? Because they don't share anything, this is basically my answer. Now I just got to write them in the different ways. Does that make sense? So, set builder, x such that x is less than or equal to negative 2, or x is greater than 3. Oops. That's horrible. But you get the idea. Who's your counselor? Yeah, she will. Interval notation. Negative infinity to negative 2. Bracket because of the equal to, right? Union, because there's 2 parts. 3 to infinity. Really nothing different. Right? So far. Okay with that? Any questions on that?
Another one.
Just want a good one. I did one right there. Okay, once again, how about I give you a pause and you guys keep done, but I'm going to keep going just for time's sake. Okay, I'm going to subtract, divide. Does everybody understand subtract, divide, why I'm doing so? I can just do it quickly. Notice, did I divide by a negative? No, hence the sign stays the same, right? I mean, we feel good? Any questions there? Okay. Number line this sucker. Here's 0, here's -2, here's 1. I'm going to do this guy in black. So that's saying, oh, that kind of looks like the equal to, doesn't it? This guy, oops, this guy in black. Okay. So that is saying, oh, open this direction, right? Is everybody there with me? Correct? Purple. This guy's going to be the purple. Where does he start at? -2 and open, but this way. Right? Once again, what does an or statement mean? What did I talk about? Where one of them works, or where the other one works, or where they both work. So, does somebody work over here? Does somebody work in -2? The purple one doesn't work in -2, but does the black one work in -2? How about in between? That's where they share, huh? That one, the black one doesn't work there, but the purple one does. And then notice the purple works here. So isn't every answer being covered? Okay, in an or statement, that means anywhere I pick, it's going to work. Pick any number, I don't care. Somebody tell me. 172, okay? 4 times 172 is a big A number. When I add 3, it's a big A number. Is that greater than -5? It's true. So does that automatically make this true? It does, doesn't it? Okay, give me another number. 10. Okay, that's over here. I've already done that. Let's do -10. That's -40 plus 3. That's -37. Is that greater than -5? No, that does not work. But when I plug it in here, times by -10 is -40 minus 5. That's -45. Is that less than 3? That works. So it's like I said, once again, the movie idea, right? As long as somebody's doing it, it's okay on an or statement. Hey, what if we pick 0? It works here and it works here. Even better, huh? Okay, so what's my answer to this? Is this my answer? No. As it's an or statement, my answer is X such that, how do I say that everything works? All real numbers. Have you guys seen that before? Now here's a little symbol for you guys. Real numbers, you do 2 lines like parallel lines and then make an R out of it. That means real numbers. Okay? So X, here's my brackety thing. X, now this is like a little E, such that, or it says X such that X belongs to the real number. That's my set builder. Okay? Does that make sense, everyone? How do I do my interval? How far left does my answers go? -infinity. How far right does my answers go? Infinity. And isn't that basically saying every number in between, which is all real numbers? This would be my answer. These, after I graphed them, showed us a different solution because of the or word. Now, I'm going to continue on just for a minute here. We're going to use the word and. Shereen talked about me and her in the movies. If she went and I didn't, is that a true statement if I use the word and? No, that's false. If I go and she didn't, is that a true statement? It's where we both have to go, right? So if this was the word and, what would be my answer? Where they would share, correct? Where they share. So if it was an and statement, my answer would be -2 to 1. In the interval. I'm just going to do the interval, not the set builder. Okay, does that make sense to everybody though? I guess the set builder would be X such that X is greater than -2 but less than 1. Is everybody with me there? Okay, last example. Sorry we got Missy's conversation. Freaking took you guys. Okay, last one more. Where is it? Right? Okay. When you see something like this, how many equations do I have? 2. Let me cover this up. I know it's on top of my hand. But there's an equation, huh? Right? Here's an equation. You guys see how there's 2 equations, but it's just in one? Okay. Whenever it's like this is automatically an and statement. I could actually rewrite it. That's an and. You guys all know that, right? I could write it like that and see how I have my 2 solutions there, or my 2 option pieces. Okay, but I'm going to just do it like this. I'm going to show you how to solve when it's in this case. Okay, it's 2 equations. How do I get rid of that 2? Subtract it, right? Subtract it from here. If I do it to here, I got to do it over here because that's an equation, correct? But if I do it to this equation, I got to do it to this equation as well. I got to do it to 3 parts instead of 2 because there's 2 equations. You guys see how it's the same thing if I would just solve it from this guy? Right? Okay, so I'm at 1 is less than negative x, which is less than 5. Now what? How do we get rid of that negative? Divide, because it's timesing by negative 1, right? Okay, so that's negative 1. Oh, if I divided, so what do I, by negative, what do I got to do? Flip them, huh? Okay. So on my graph, this looks like this. Here's 0, here's negative 5, here's negative 1, and where is x? Notice if I erase this part, that's saying x is less than negative 1, so that's this part. Correct? This part saying x is greater than negative 5. But once again, if that was an OR statement, that'd be infinite solutions. That's not an OR, this is an AND, so we're looking for where they share. Where does it share? X is between negative 1 but greater than negative 5. Basically, it's just this, but in a better way to write it. So my set builder, right? What would be my interval? How far left do I get to go? Negative 5. How far right do I get to go? Negative 1. Those are the parts that work for both. Right? Does that make sense? On AND, they have to work for both areas. The only part that works for both areas is this. Right? Okay. Any questions? Okay, that's it.